In this video, let us solve this problem. So we have a vessel containing 50 cm cube of a gas at 200 milliliter mercury, and the temperature of the gas is 47 degrees Celsius. If the pressure is increased by 70% of the initial pressure, while the final temperature is 93 degrees Celsius, find the volume of the gas at this final stage. To solve this, let's first write out what we were given. So we are given that the vessel contains 50 cm cube of gas. So this is the volume of the gas right at this pressure. Now this volume right here is the initial volume. So initial volume V1 is equal to 50 cm cube, okay, at 200 millimeter mercury at this pressure. So this is the initial pressure of the gas. So initial pressure P1 is equal to 200 millimeter mercury. Okay, good. And the temperature of the gas is 47 degrees Celsius. So the initial temperature of the gas is 47 degrees Celsius. So T1 is equal to 47 degrees Celsius. So let's then convert it back to Kelvin by adding 273 to it. Okay, so 47 plus 273 is equal to 320 Kelvin. Okay, good. So if the pressure is then increased by 70% of the initial pressure, so we have that the second pressure right now, P2, is increased by 70%, and 70% is 70 over 100. So 70% of the initial pressure, which is P1. Now don't forget that P1 is 200, right? So equal to 70 over 100 times the value of P1, which is 200. 200. 70 times 200 over 100 is equal to 140. So P2 is equal to 140 millimeter mercury. Okay, good. So continue with the question. We have it that while the final temperature is 93 degrees Celsius, so the final temperature, which is T2, right, is equal to 93 degrees Celsius. Okay, so then convert it back to Kelvin by adding 273 to it. 93 plus 273 is equal to 366 Kelvin. Okay, good. Find the volume of the gas at this final state. The volume of the gas will then become V2 is equal to the unknown question mark. Okay, good. So to solve this, we're going to apply the general gas law, which is given by P1 V1 over T1 is equal to P2 V2 over T2. Good. Now inputting our value to solve for V2, P1 is 200, so 200 times V1 is 50 times 50 over T1 is 320 Kelvin. 320 is equal to P2 is equal to 140, so 140 times V2 is the unknown we're looking for. V2 over T2 is 366 Kelvin over 366. Then to solve for V2, right, cross multiply. We have it at 200 times 50 multiply 366, so 200 times 50 times 366, okay, is equal to 320 will multiply 140 times V2, so 320 times 140 times V2. Okay, now to solve for V2, divide both sides by 320 times 140, 320 times 140, right, over 320 times 140, right. This cancel this, you have it that V2 stands alone. Now V2 is then equal to 200 times 50 times 366 over 320 times 140 is equal to 81.6 centimeter cube. And this is the value of the volume of the gas if the pressure is increased by 70% of the initial pressure at this temperature.